Okay, welcome to this lesson on algebraic fractions and formulae. Now we're going to embark on addition and subtraction of algebraic fractions. But before we begin, I think let's just recap a little bit about adding fractions. So when we add fractions, very simply, for example, if we have 1/4 plus 1/3. I think we have learned that we need to make denominators equal, right? Because we need to make the pi the same, right? Then we can add the stuff together. Make denominators equal. Okay, so this is something that we have always done, and you have always done, when we want to add fractions. In this case, we have in this case, how do we make the denominators equal? We look at the lowest common multiple between the denominators, and in this case, the lowest common multiple is 12, and so I will have 3/12 plus 4/12, and subsequently I will get 7/12. So when it comes to algebraic fractions, I think we have also learned that if we have one of the numerators as algebra, right? So in this case, we want to make these two numbers, okay, the same, and the only way to do it is the lowest common multiple here, okay. The LCM is equals to 28, and so what I'm going to do is I want to make each of the fractions where the denominator is 28. And for the first one, this would be 7x over 28. Okay, it's a process of multiplying 7. Okay, and for the second one, okay, we don't multiply 7. Instead, we multiply 4. Right, because 7 times 4 gives you 28, and we want to make the fractions equivalent. So in this case, it will be 4 times of 2x plus 3 divided by 28. And there we have the fact that we can combine them once the denominators are the same. Let's expand it out. Okay, and then we simplify as much as we can. So 15x plus 12 divided by 28. Okay, you don't have to factorize here. There's no point because there's no common denominator between the numerator and denominator. So this is how we do it. Now, in today's topic, we're going to look at what happens if you have algebraic terms and your algebraic variables in your denominator. So for example, right here, we have 3 very simple examples. The first one we have is 2/3a plus 3 over 5a. Now looking at it, okay, the denominators here are 3a and 5a. So how are we going to make them the same? Okay, remember just now we had, if it's 4 and 7, okay, we look at the lowest common multiple by multiplying 7, and this one I multiply 4, right? Okay, it gives you 28. Okay, not all cases where it's nice, it will give you something. Now for this case here, we have 3a and 5a. Now a is multiplied. You cannot remove a, right? The only way is to manipulate the number. Okay, a is a common factor already, so that's great. The only way is actually, in fact, to multiply 5 and multiply 3, and in this case, it becomes 15a. Okay, so can you see that is how we make the denominators equal? We multiply a certain number. It may be different, but the goal is really simply to make the denominators the same. So for 3, I multiply 5 to the denominator. I must also multiply 5 to the numerator, and hence I have 10 over 15a plus the other side will be 5a times 3, so it will also be 15a. Okay, but on top will be 9. In this case, we have 19 over 15a. Okay, so the goal is simply really to just make denominators the same. Alright, let's look at the second one, b. B is a little bit complicated, so maybe before we do it, let me try just factorizing something out. So in this case, I'm going to factorize the denominator first. Okay, reasoning is because I want to find a common nullity, a common point between the denominators, such that it will aid my multiplication of my denominators easier. So I'm going to factorize 2 out, and then from the other side I will factorize 3 out. Now from here, can you see that actually the numbers, the factors, the common factor now is b minus 2c, and what's different is only the 2 that's multiplied and the 3 is multiplied. So actually I don't really have to be bothered too much about the b minus 2c. I don't actually have to, like, remove it. I can just leave it there. But in fact, if you look at the denominators carefully, okay, what you're going to play with is the numbers that you factorize out. We're going to increase this number to ensure that the denominators are the same. I will actually multiply a constant to ensure it becomes the same. So in this case, I'm going to make the denominators 6. Okay, so what we have here is I'm going to multiply 3 to both sides of the first fraction. So it will be 6 times of b minus 2c. Okay, what's going on here? Let me just write it here. I'm just going to multiply 3 to the top and bottom of the fraction. So for the other side, instead of multiplying 3, I will multiply 2, and hence I will get 4 over 6 times b minus 2c. Now from here, I want to emphasize again, the goal is really making the denominators the same, and it is a very simple concept that you need to take away from this lesson. And right here we combine them. So once you have the same denominator value, you can combine them and you will get here. Okay, remember, you cannot add the denominators together, right? Because if you look back on here, do we actually add the denominators together? We only add the numerators together, right? Numerators, yes, but denominators, no. Okay, so some point to take note, we do not add denominators together. Okay, we only add numerators or subtract. Okay, maybe it's subtraction as well. Only if denominators have the same value. Okay, this is a major takeaway that you need to have when it comes to simplifying such fractions. Okay, so that is the answer for part B. Please feel free to pause this video anytime if you want. Okay, now let's go on to this. This is a little bit tricky because your h minus 2k, it's kind of like, separate. But let me just show you what is happening here. Can I actually write that 2k minus h is equals to negative h minus 2k? So this is just factorizing out a negative, right? Now I'm going to use this inside this fraction over here. I have 2h over h minus 2k. Now remember, one thing about fractions is that if I have negative 1/3, I can write it as 1 over negative 3. So it becomes positive, right? Kind of becomes positive on the outside, right? So if I say 1 minus 1 over 3, can I write it as 1 plus 1 over negative 3? Technically I can, right? It's just a matter of playing with the addition and subtraction sign. So I'm going to make this positive now, and I will infuse the negative inside the denominator. And when you do that, you need to introduce the bracket if there's another addition and subtraction sign inside, because you're taking the negative of the entire denominator. And with this, we're going to apply what we did here to here. So negative 2k minus h, okay, is equals to, it's actually, if I put a negative, okay, maybe I didn't write this properly. Okay, but can I write that h minus 2k is also equals to the negative of 2k minus h. Correct? So I'm gonna like reuse this property, okay, and kind of introduce to kind of like remove the negative sign in some sense, but honestly you're actually not lah. Okay, so replace the negative 2k minus h by h minus 2k, and then you have made the denominators the same, and that will be 5 because it's 2h. So you don't have to multiply anything. This whole part of part C is just infusing the negative sign in it. So it will be 2h plus 3k. Please do not try to add them up. Okay, it will not make sense. And this is h minus 2k. Okay, so do take note the learning points from each of these examples. One, A is just a very simple manipulation. B is more like, you know, how to do that with more complicated terms, and last but not least, how to make use of the negative signs. Alright, so that will be all for work example 5. See ya.